Good afternoon, students. I'm giving you the information about the elective subject of semester 5, Advanced Control System and Instrumentation. Subject code is ACDLO CR 05055 and lab code ACDLO LR 05055. Student, advanced control systems and instrumentation are pivotal in modern industries. These play a critical role in modern industries by enhancing automation, precision, safety, and efficiency. And its applications are there in recent industries. We can say this is transforming industries by enhancing automation, enabling predictive maintenance, and facilitating data-driven decision making. These technologies are essential for achieving operational excellence and staying competitive in today's rapidly evolving industrial landscape. Student, uh, in this actually what we will learn, that will be uh, four topics there. First is that is the four modules. Module one is stability in time domain and in frequency domain. We deeply learn time domain technique and frequency domain techniques. Second module is on introduction to controller design, which we will use, the controllers we will use in industrial automation. To design the controller, we should have the knowledge of time response analysis and frequency response analysis. Third module, we will learn state space analysis. And fourth module, we will learn signal conditioning data acquisition system, data logger, and SCADA. Students, these topics on control, first two module are on control. They are used in controlling the industries and in application of automation, industrial automation, and robotics. And last topic is on instrumentation, that is how the signal conditioners are work with data acquisition system, with data logger, in which we will process the data, we will store the data, and SCADA, supervisory control and uh, data acquisition system. So students, where this we will use. So first is the manufacturing and industrial automation. That is robotics and CNC machines. Now, all machines are becoming automatic, and working of CNC machines are increasing day by day with process control. Process control is real-time control of temperature, pressure, flow, and chemical composition. Then predictive maintenance, in which we will use the sensors and control algorithms to detect anomalies. So this is the in industrial application in manufacturing and industrial automation. Second, the application in oil and gas, that is drilling automation, pipeline monitoring, and in refinery process control, in which we use advanced PID, proportional integrated derivative controller, DCS, distributed control systems, MPC, model predictive control. So this is the advanced control system. Then next use of this learning of this subject, where we can do its applications in power and energy. Example is smart grids, in which real-time load balancing, fault detection, and integration of renewable energy. Then power plant automation, turbine control, boiler control, and load dispatching. Then battery management system, control systems optimizer charge discharge cycles in electric vehicles and storage units. What I am telling you, these all are the applications of the control systems, advanced control systems and instrumentation. Fourth is in aerospace and defense. So flight control system, where we use advanced PID, proportional integral derivative controller, adaptive and fuzzy logic controller. Then we can use this study in navigation and guidance, integration of sensors and controllers in drones and missiles. Then in health monitoring, real-time monitoring of structural integrity using smart instrumentation. Then fifth use is there in automotive industry. So autonomous vehicles, which are based on sensor fusion and control algorithms for navigation and obstacle avoidance. Then engine management systems, in which optimal fuel air mix and emission control, that is the engine management systems. Then advanced driver assistance systems, which we are used in real-time lane keeping, adaptive cruise control. Then there is the next use of this control system, student, which we will study. That is in pharmaceutical and biotechnology. Actually, in the subject, first we study the time response analysis and then frequency response analysis. and then design of controller. And the third is state space analysis. So these we can use the control unit. And fourth chapter, we can use transducers and sensors in for the sensing element, and which we can use into the modern industrial automation. So six is the pharmaceutical and biotechnology. Example, we can give process analytical technology, bioreactor control, where precision control of pH, temperature, dissolved oxygen, then sterilization and clean room monitoring we can do with this control system. And process analytical technology, we can do monitoring and controlling quality in real time during drug production. Next use of the control system and instrumentation is food and beverage industry. Example is batch processing control, ensuring consistency in taste, texture, and safety. Packaging automation, instrumentation for fill levels, sealing, and labeling. Cold chain monitoring, real-time temperature control during transport. Then next use we can say water and wastewater treatment, SCADA systems, supervisory control for water distribution and treatment, sensor networks, monitor turbidity, chemical composition, and flow rates, energy optimization, using control strategies to reduce energy usage in pumping and aeration. So these technologies are very useful, student, which we will use with the help of PLC, Programmable Logic Controller, DCS, Distributed Control System, SCADA, Supervisory Control, and Data Acquisition, or AI-based data control. And this is very important in industrial landscape. Throughout the world, this is very important. All the technologies are important. In military and applications also, to design the missile, from the design of the missile till to fire the missile on the target, it comes under advanced control system. So you can imagine how the subject is important. So real-time application and real-time use in day-to-day life is done with advanced control system and instrumentation. As I'm being electronics and computer science engineer, if you have the knowledge of this subject, then you can do the application of control system and application of control system and instrumentation to the to gain the required product in industrial automation. Right. So this subject is kept as elective in semester 5. Okay. So if you want, you can choose this subject. This is very important as everyone is learning software. But where that software should use, that is also important. To design the control system, to design the automation, to design the robot, to design the electric vehicle, to design the PLC, to design the DCS, distributed control system, to design the SCADA. This software is important, and for that purpose, this subject learning is important. Okay, so now the decision is yours. I have given the brief introduction of this subject. Okay, thank you. So we'll stop here, sir.